I will welcome Wille to present on Cloud Native OSM for visualization and analysis.
Good morning. I'm Wille Marcel. I'm going to present a talk named Cloud Native OSM for visualization analysis. I'm a software engineer at Development Seed. So we are going to talk about cloud native data formats, or they are also called cloud optimized data formats. But the first question is, what are cloud native data formats? I think a good way to explain that is that, for example, if you just want a slice of cake, you don't need to buy the entire cake. You just get the slice. Or for example, when you're watching a YouTube video and you move forward, for example, for the last minute of the video, your browser will not download the entire video. The browser will download like just the section of the video that you want to watch. The data, just close cloud optimized data formats works the same way. You have like a data set, a file with, let's say, for example, the global OSM data, for example, and when you load a specific city, you are not downloading the entire global data, but just that city data. So those formats enable efficient on-the-fly access to geospatial data. It has reduced the latency as it gets only the part of data that you need. You can get only some subsets of the data. It's generally those formats are binary, so it's processed much faster. It can scale well as it is on the cloud. It gives you also a lot of flexibility because you can filter, you can tailor the data access to your needs. And it's also very cost effectiveness because as you are transferring less amounts of data, you pay less for the data transfer, and also generally they have good compression options that also reduce the costs of storage. We have a guide about the cloud native data formats on that website. You can check it later to know more about it. So some of the file formats, like generally the vector data, I think most people work with Shapefile or GeoJSON or GeoParquet. The equivalent of cloud optimized file format would be something like FlatGeobuf or GeoParquet. There are some data points, cloud point formats. Also, when you are talking about raster, the common format is GeoChif, and there is a version of GeoChif that is cloud optimized GeoChif or COG, and some other formats that are less used, but a bit more complex. And also there is PM tiles that is, I think, an upgrade over the MB tiles or Mapbox vector tiles. When you need to visualize large amounts of data, PM tiles with just one file stored on a server, you can do just range requests, like and get some specific data that you want to visualize. And it's very cheap to host PM tiles, and it has supports on many map libraries like MapLibre. So generally, when we are getting OSM data, we use some extracts websites where generally you download the entire country data or some region data. There is also Overpass that is a fantastic tool. However, it has some limitations on like the amount of data that you can get because of timeouts on the servers, and also what you can visualize on Overpass Turbo, for example, because the data comes in a format that is not very efficient for web. And when you are dealing with something like 10 megabytes or more, probably your browser will not support it. And Overpass, you can get, I think, I've tested it with something like 150 megabytes, like not visualizing the browser, but just downloading your computer. It works well. But yeah, sometimes you can reach some timeouts, or the data is too much to download. So yeah, many users of OSM data report some issues like there is lots of places to download the data and not a central place, what can be good in some aspects, but also confuse new users. Most options require you to download the entire country data, or you have to filter it after downloading. You are dealing with large amounts of data, and sometimes open it on something like QGIS. It's a bit slow and requires some time to process. And some formats are also not ready to use on the web. So on development seed, we have been experimenting with some of the possibilities to deal with OSM data using some of those cloud-native formats. The first experiment that I'll show is just a prototype of, I converted some OSM data to PM tiles. In that case, I think I have here entire Kenya data. It's loading, I think. Yeah. And we are playing with filtering that data directly on the browser. So we can, let's say, combine amenity and shop. And so everything with those two tags are rendered here. We can do other things like building. I don't know what the browser is cutting here, but yeah, we can get, we can visualize instantly the buildings. We can also add more filtering, like let's say buildings with name. And yeah, like all the data is already here and the filter is very fast. We can do something like highway, and we can combine it with another filter, only highways with surface tag or some specific value, and add more filtering, and then like the prototype was like to explore what's possible to do when all the data is already on the browser and you can visualize it faster and filter it in a very efficient way. The other prototype is using the vector data that contains mostly OpenStreetMap data. On development seed, we created a library named Longboard that brings some power to visualize, to have web maps inside the Jupyter notebooks and allow to load like GeoParquet data or other cloud formats like FlatGeobuf direct inside Jupyter notebook and have interactivity and everything that a browser can give you. So here, I basically yeah, I download the buildings data inside this B box. And then here I download the segments data from that B box and filtered only the roads. And with that component, the Lombard component, I can visualize it inside a Jupyter Notebook. And here we have some colors based on the number of levels of the buildings. And we can see here that few buildings here in Nairobi have the information about the levels. And we can also, oops, let's zoom in. Yeah, we can also see some details about the features, like the source, the class, like service road. Or in the case of the buildings, we can see that building does not have the number of floors. Yeah, over to convert some data, some tags to other columns, names. And then, yeah, we can interact with the data. It's like a lot of data that we can visualize in a very effective way, a very fast way in the browser, and it gives you lots of possibilities. Yeah, we have in the Lombard website the documentation about lots of examples of dealing with some massive data sets and visualizing it in the browser. The other part of my talk is about something that we have built in the OSM data pipeline. For those who don't know, OSM is one of the main validation tools for OpenStreetMap. I started that project 9 years ago, and it has been used by the community, by many organizations as well. And like most people just know the interface of OSM, like where you can visualize the change sets, you can filter it, you can review, add comments to the change set. OSM provides a good visualization of the change set, but there is much more behind it. And it is the data pipeline that we have on OSM that feeds the OSM. So each minute we are processing the OSM data, we are processing the OSM replication files, we are getting data from overpairs as well, and we store the change sets in a database. Then we have the API that is used by the front end to get the change set data. But we also combine the overpass data that gives us like the features that were modified, created, or deleted on each change set with some metadata come from the OSM replication files. And we have a service that we call it OSM AGIF service. And the main result of that service are what we call the real change sets. So yeah, we have the API that you can use to fetch the change set data. All the information available on the front end is also available on the API that you can use it. And we have those real change sets. So it's basically, in order to visualize a change set, generally what we do is like a query on the overpass and get the data about that change set specifically. But carrying overpass, it takes some time, and we thought that it should be much more faster and effective if we do that query one time, store it on an S3 bucket in a JSON format that is much faster to get. So it's what we call real chain sets. It has like for each feature inside the chain set, we have the tags, the user that created it, and also the old version of that feature. So with that, we can provide that visualization that you can see here. And it also gives us other possibilities, like, for example, executing some scripts to read that information on the real chain set and check for data inconsistencies, data quality issues. And the real chain sets are available for free in our AWS S3 bucket that is sponsored by the AWS Open Data Program. Then we decided to also play with those real chain sets and see what we can do if we use some cloud optimized format. So we created Gradient. It's basically get all the chain sets in 1 hour and store it as in a flat GeoBuf file. And yeah, and each file contains like all the data modified in OSM in 1 hour. So, oops. Let's see. Here. Yeah. Right. So here we can see all the data that was created, modified, or deleted on OSM in the, I think, September 2 at 8 a.m., between 8 and 9 a.m. And we can like go forward to the next hour, for example. Yeah, it's takes some seconds. The good thing about FlatGeobuf is also that you can compute the statistics about the data. Like, for example, here, some statistics about buildings, highways, and other features, like the main users, some other tag starts as well. And we can zoom in, oops, and visualize the data close. And also, the browser is a bit slow, but yeah, we can check each feature, see the tags, the user that interact with it. And yeah, we have been playing like what we can do. Also, if you have the data in a format that is efficient to read and to get. So yeah, you can try Gradient already on the gradient.osmchat.org. Yeah, this is the view. Here, for example, we are visualizing data modified in Europe in some hours. With FlatGeobuf, it's also possible to combine multiple formats in just one file. So we can do something like combine all the files for one day and visualize it. So thank you. Let me know if you have some questions.
Hello, this is Benny from Higet. Thanks for your interesting talk. We also played around a lot with tools that you created, like a Lombard for visualization of GeoParquet, super nice. For the last thing you showed was Gradient and the connection with OSM char, what is the use case you had in mind when you built that? So is it us kind of validating OSM data, or yeah, why did you build this?
I think the first idea was like, let's try to sort that data in a most efficient way. And also sometimes like people don't want to review chainset by chainset. They want to see everything modified in that area in a period of time. So yeah, being able to do that could be a good possibility for the users as well.
I have two questions. The first one was to be sure regarding the real chainsets. They are, I mean, basically the chainset information that you can find in XML format, plus some information about tags, or I mean something that is not in the OSM chainset files. Yeah, okay. And is it available worldwide? I mean the real chainsets. We can I mean retrieve them where it's and what is the update?
It is an AWS S3 bucket, and we also have a URL that you can use to get a specific file. I can send you later that URL, or you can also inspect the request on SM chat. That when you load the chainset, you see like some requests to real chainsets, and that URL is like some AWS URL and / the number of the chainset.json.
Thank you, Wille. We'll go to the next session.